The Subcommittee for Aircraft Accident Re-Investigation presents the results of research conducted in the case of the crash of the TU-154M PLF-101 Polish Air Force aircraft on the 10th of April 2010 in Smolensk. Fragment of the last speech of the late President Lech Kaczynski, which he did not manage to deliver on April the 10th, 2010 in Katyn. The murdered people are Polish citizens, people of various faiths and professions, military, police, and civilians. The starting point for the Commission's work was an analysis of the decision on the renovation of TU-154, followed by preparations for a visit to Katyn. I do not even know that there is an airfield in Smolensk. A flight to Smolensk, military operations in Polish and Russian civil services. The Commission examined in detail the history of extraction and reading of black boxes and flight recorders and their reliability. It reconstructed the trajectory of the flight, the impact on the ground according to the Mack and Miller's Commission. The path of the test approach and departure to the second incident of TU-154M pilots was thoroughly examined, which has not been done so far because it was assumed that the examination of events after a hypothetical hit on the birch tree is no longer relevant. The Commission, in cooperation with NIAR, National Institute of Aviation Research in Wichita, USA, Military University of Technology in Warsaw, and Institute of Aviation, reconstructed the structure of TU-154M with millimeter accuracy and simulated its flight and impact on the ground. The exact distribution of the aircraft remains over the entire area of its destruction, and the bodies of fallen passengers was also reconstructed. An important part of the Commission's research was played by simulations of explosions in the left wing and in the center plane of wing, reconstructions of the disintegration of individual parts of the aircraft and pyrotechnic experiments. The decision-making process for the investigation of the crash was also analyzed, as well as the proceedings of the prosecution and aviation commissions. At the request of the subcommittee, studies were carried out in the USA on the remnants of traces of explosives on the remains of TU-154M No. 101 and TU-154M No. 102 aircraft. Moreover, a huge number of calculations and hundreds of analyses were carried out in the field of physics and aerodynamics, which confirmed or ruled out possible hypotheses of events of April the 10th, 2010. Correlation of the results of all these studies allowed to answer what actually happened over Smolensk on the 10th of April 2010. The key factor enabling reliable verification of the report of Russian General Tatiana Anodina and the report of the administration of Donald Tusk under the leadership of Minister Jerzy Miller was to reconstruct the model of the plane and to carry out appropriate finite element simulations in the LS-DYNA program. This was done in cooperation with NIAR based on data from the TU-154M plane No. 102 preserved in Poland and thanks to detailed reconstruction of the remains of TU-154M plane No. 101 in the wreck, as well as analysis of preserved technical data of the plane. This is the most accurate and detailed reconstruction and simulation ever undertaken. It consists of over 30 million finite elements. The plane TU-154 No. 102 was scanned, each single part of the plane, and this data was supplemented by a reconstruction of the remains of TU-154 No. 101, additionally supported by the preserved technical data of the plane. For the simulation in the LS-DYNA program, all the finite elements were assigned physical properties of the materials from which they were built. Having such a detailed model of TU-154M, the aircraft was simulated according to the data and position of Mack and Miller Commission. Despite the use of enormous computing power of supercomputers located in Poland and the USA, the conversion of such huge amounts of data took a very long time. This research made it possible to scientifically verify the journalistic theses contained in the reports of Tatiana Anodina and Jerzy Miller and helped to gather evidence indicating the actual causes of the catastrophe despite the destruction of evidence, falsification of expertise, and dissemination of disinforming theses by the Russian side. According to Minister Miller's statement, the main aim of his report was not to explain the catastrophe scientifically, but to defend the Russian version of the Smolensk tragedy. Either we take care of a uniform message that does not encourage myths and suspicions, or we're going to wring a whip on our own backs. Even the members of Miller's committee had doubts about the propaganda theories put forward by the management and administration authorities of Donald Tusk. Because I have a question, if you can, to all members of the committee. On what basis can you say that General Błaszczyk was in the cabin? Because here, he is still. It's still, but that basis is questionable. For a simple reason, everyone knows what the TU-154 looks like, and the compartment in front of the entrance, so to speak, to the cabin. If somebody was standing in the aisle, for example, at the moment of hitting and sliding, so to speak, or sudden braking, after all, it is normal. If I am in the corridor, I will immediately find myself in the front part. I will fall into the cabin. However, from the beginning, a clearly formulated goal sanctified the means. Without any scruples, creative corrections of evidence and expertise were made. Here we have again from small GIS expertise the probable blast zones of 14 and 9 meters in diameter. That is here and here. It is very badly written. It has to be eliminated. Maybe fires? I mean, we can make a creative correction at once. Here, we'll put in, yes, zones. Okay, fire zones, good. And no diameters? No, probable. From the first days, evidence of Russian responsibility was hidden. You present how the last phase of the flight looked like, formulating quite a thesis that surprised everyone, namely that it was Russian. I mean, this thesis was not surprising, but the fact that it was formulated at such an early stage of this thesis. There you have put it in bold print that the Russian side is responsible. That the Russian side is responsible? Because it did not close the airport, right? Maybe it's that it's... Oh, it's probably something. If this is my report, then I don't think so. I think, well, there were no facts and data that could not be creatively corrected. I wanted to point out that it was because the tree was shifted in time. For 5 months, no one noticed that there was a different time. And that's why everything has been changed on the approach, because only recently someone noticed that the tree has to be at the moment when it is 2.8 seconds. And that's why it has been changed. And until then, no one has analyzed it. So that we do not have any problems in future, this tree might shift again. Already in the first minutes after April the 10th, public opinion was disinformation about the causes and course of the catastrophe, although initially even Putin claimed that it happened over the wreck itself. The first impact was 200 meters from here, and since the landing gear was already released, everything took place here later on, and part of the plane disconnected and fell over. Among numerous false information in the media, a hypothesis about an armored birch tree was particularly strongly promoted, which was supposed to cut off a fragment of the left wing and in effect lead to the destruction of the plane. Therefore, the presentation of the results of the committee's work will begin with a simulation of a collision between the plane's wing and the birch. As the reconstructions of NIAR have shown, a hypothetical hitting of a birch would cause it to cut through the wing of the plane. In this collision, assuming the scenario of Mack and Miller Commission, this TU-154 wing would cut the birch, not the other way around. The birch is cut evenly. It's completely different from a broken tree in Smolensk. Also, the destruction of the wing is fundamentally different from that of the TU-154. It is clearly visible that the Smolensk birch was not cut, but broken and certainly not made by the plane's wing. Furthermore, all tests in aero and hydrodynamic tunnels have shown that the cut-off wing, according to Mack and Miller's assumptions, would not cause the plane to hit the ground because the loss of such a fragment of the wing would be compensated by putting the plane in the slide. This happened when around 100 meters before the Bodin birch, the explosion destroyed the left wing, and then the autopilot and pilots put the plane into the slide. In turn, liars from Smolensk also hid the fact of finding the first remains of TU-154M several tens of meters in front of the birch tree, and the fact of hovering on branches of this tree other remains, including the rib of the wing torn out from the inside of it by the explosion. In order to hover on branches of this tree, these parts of the TU-154M needed to be pulled out of the wing at least 40 to 60 meters earlier, as this was shown by the experiment carried out by the subcommittee. The subcommittee asked the team of scientists at the Institute of Aviation Research in the USA in Wichita, working for the world's largest corporations Boeing, Airbus, and Bombardier, and ordered a numerical reconstruction of TU-154M number 101 and a simulation in the LS-DYNA program of the Smolensk catastrophe, according to the data contained in the Anodine and Miller report. After reconstructing the flight path according to the data from Mack, it turned out that the plane would hit the ground with its wing just behind Bodin's birch tree before it would lift the shed on this plot. It is difficult to even understand how the Miller's Commission could have concluded that the Bodin birch broke the TU-154 wing, flying 5 meters above the ground, without destroying the shed standing there. It is no less difficult to understand how many scientists, politicians, and journalists still repeat this absurd thesis today. Nothing better shows the political conditions of the Miller-Lasek Committee and its supporters. The birch had to cut the wing and lead to the catastrophe. Otherwise, the question of how this really happened and how the wing was destroyed would have to be answered. In the analysis of NIAR trajectory, Mack shows, however, that even if the plane flying 5 meters above the ground reached the crash site, it would have fallen in a completely different place than it really happened. The Mack trajectory ends not at all in the place where the first traces of the impact on the ground, the so-called furrows, begin, but many meters to the northwest, and this in a position almost perpendicular to the direction of the scattered remains. In short, an airplane flying according to the Mack trajectory could not have crashed as it did in reality, as it would be flying not with its bow and cockpit to the west, but with its left wing, fuselage, and vertical ballast. It was then decided to reconstruct the course of the catastrophe according to the parameters indicated in the Miller and Mack report, modifying its path so that it would hit a birch tree at a height of 6.75 meters above the ground, according to the assumptions of the prosecutor's experts, and then fall in the place of the beginning of the furrows in a position inverted by 150 degrees. Thus, it is a reconstruction of the events in line with the opinion of supporters of Miller, Mack, and the prosecutor's office, whose experts say that was CFIT, controlled flight into terrain. Here's the result of this test. The plane, hitting the ground in an inverted position, crushes the fuselage in the part in front of the center plane of wing, but the structure of its structure is maintained. The cockpit moves on the ground at the highest speed to the west. Behind it, there is a center plane of wing not broken in the vertical axis. The center plane of wing slows down much more than the cockpit, probably due to a deeper impact on the ground. The sides of the machine bend inwards, not outwards, as in Smolensk, and the center plane of wing is not broken. Also, the hull behind the center plane of wing does not rotate in the air, bending the sides outwards as it was in reality. On the contrary, the sides of the hull bend inwards, and the passenger door of the left side, instead of being pushed 1 meter into the ground, glides several meters on the ground and crushes. The pants of the tail plating in the simulation are crushed inwards, while in reality it is intact in the wreck. At the same time, the upper part of the tail's septum breaks down and disintegrates, pushing the fragments of the bathroom and the fuselage into the rear fuselage, pushing the bodies of the passengers towards the center plane of wing. Meanwhile, during the catastrophe, the passenger's body from the last row of seats was pushed into the tail baffle, where parts of the bathroom were also located. The NIAR simulation starts when the plane hits the ground. For calculations, the conditions given in Miller's and Mack's reports and in the studies of the Military Prosecutor's Office were used. The simulations carried out show drastic discrepancies between the results obtained and the disintegration of TU-154-101 and the scattering of its parts on the wreck. The first element is the door on the left side of the plane, which has been driven more than a meter into the ground. The simulation shows the process of destruction of this door, which, after a moment of sliding on the ground, bounces and flies in the air many times farther than the TU-154. Already in the earlier simulation, NIAR showed that to knock them into the ground, it takes more than 10 times more vertical speed than the one the plane had. Now, it is clearly visible that at a lower speed, the doors bounce off the ground instead of bumping into the ground. The next element that draws attention is the passenger part of the hull behind the center plane of wing. During a simulated impact to the ground, the roof and sides collapse and are pressed into the interior. A catastrophe visible on the wreck is reversed. The pictures show the roof being torn apart and its sides being rolled up together with the sides outside. The same goes for the middle engine in the tail of the plane. During the simulation, this engine is torn out of its housing and pierces the tail of the aeroplane. On the wreck, it is still in its place inside the tail. The next part of the plane is a pressure bulkhead. It maintains constant pressure in the aircraft fuselage and isolates it from the hermetic tail. During the simulation, the tail of the plane breaks away from the bulkhead attached to the fuselage. On the wreck, on the other hand, we see the tail pulled out and the bulkhead connected to it. The last elements of the presented examples are vertical and horizontal ballasts. According to the simulation, these ballasts broke away from each other. On the pictures from the wreck, it is clearly visible that these two ballasts, despite the damage, were still connected. Finally, one of the most important simulations made by NIAR and the University of Akron, showing that this wing of the plane would cut the birch tree if such an impact were to occur at all. The results of the simulation could be precisely compared with the actual state of the wreck, because the subcommittee, on the basis of tens of thousands of photographs, identified a huge number of parts of TU-154 in the area of the crash site, all of them indicating the real causes of the plane crash. So the TU-154M plane hitting the ground according to the perimeters indicated by Miller's report crashes completely differently than in Smolensk. The results of these studies are consistent with those of Professor Grzegorz Szulaziński, a specialist in the finite element method who conducted a simulation of such a situation. In this case, too, it turned out that an airplane hitting the ground in such a way would neither disintegrate into tens of thousands of fragments nor suffer damage scattering individual parts of the airplane, as it can be seen on the wreck. Unfortunately, Anodina and Miller have never verified their stories, nor has anyone else done so in the last 10 years except the subcommittee. Subcommittee established to re-examine the causes of the crash TU-154M on the 10th of April 2010 in Smolensk. There is no doubt that the tragedy consisted of a number of conscious actions, both in the area of the repair of the plane, TU-154M, number side 101, the way the official governmental delegation to Katyn was prepared. Actually, I do not even know that there is an airfield in Smolensk. I even read the head instructions, which I didn't read when I signed it. In this case, what you did next as the coordinator, which results from the HEAD instructions, nothing. The conscious false bringing the plane to land 1,000 meters in front of the airport by Russian controllers, as well as the failures and explosions that finally destroyed the Tupolev and led to the death of the President of the Republic of Poland, and the entire governmental delegation flying to the 70th anniversary of the genocide in Katyn in 1940. Numerous studies and experiments have shown that the theses of the Russian Federation reproduced by the Miller Commission have no scientific explanation, and the actual course of events was established. The 2009 approach cards, which are Xerox cards, contained information already outdated. Russian flight controllers were bringing the plane so that the TU-154M threatened to hit the ground 1 kilometer before the airport. This task was entrusted to the most experienced commanders, navigators, and pilots. In Moscow, in the Transport Aviation Command codenamed Logika, the operation was supervised by General Benediktov, former commander of the Russian Special Forces in Afghanistan, in Tver, where the base, of which the Smolensk airport was a part, was stationed. General Shipko, experienced navigators, Plusnina and Rizhenka, were appointed to the navigation service. All of them were supervised by Colonel Krasnokutsky, a former commander of the Smolensk base, directing the whole operation in Smolensk without any formal attachments. However, the final decisions to bring the plane were made by the main center of the Zone Integrated Air Traffic Organization System of the Russian Federation. TU-154 has not been sent back to the alternate airport. From the very beginning, Russian navigators were giving false information to pilots as to the airfield circles, point of entry to the path, subsequent distances from the airport lane, and weather conditions. The TU-154 was allowed to land, although the weather did not allow it. They were not sent back to the alternate airport, although the navigators demanded it from their own command, and the main center and Russian aviation regulations obliged them to close the airport. Polish pilots correctly made an overflight circle in Smolensk. This is evidenced by the copies of approach maps to Severne Airport from the Moscow Center for Automated Air Traffic Management provided by the Russians in May 2015. These maps show the successive positions of the aircraft and 6 readings from its transponder, which gave, among other things, a barrack height relative to standard pressure. In this official document of the Investigation Committee of the Russian Prosecutor's Office, in the last 4 readings from the transponder, the barium heights entered there were sealed. The above-mentioned above circles can be synchronized with the geographical map of the Smolensk area. In this way, it is possible to reconstruct the approach of the plane to the Smolensk airport, made in accordance with the aviation practice. The situation changed on the last straight when the plane entered the approach path. The landing zone manager from the airport tower consistently reported an underestimation of the distance from the beginning of the runway and did not correct the deviation from the axis of the runway. As a result, the plane would have crashed 1 kilometer before the runway and south of it. At a crucial moment, the navigators became silent at all, leaving the plane to their own fate, although they were obliged to make a decision about leaving the plane to the other side, and then gave the command "Horizon" instead. This is a very important case, I mean of the approach to landing performed by Captain Protashchuk. This approach was performed 100% in accordance with the aircraft's flight manual, which describes this in Chapter 6 and 8. He did everything correctly. The airport to which he flew, in Smolensk, was equipped with a very important radar. It was the precision approach radar, where the height of this approach is being decided when the ground is not visible. And what was done in the cabin of this plane was in accordance with the instructions and what this precision approach radar reported. It is very important that the controller working on the radar could at any time, give to the crew their position in relation to the descent path and in relation to the central axis of the runway. And so, from the materials we are currently using, we know that the controller told him several times that he is on the descent path and on the course. While we know that the plane was slightly to the left and from the central axis of the runway, he should have corrected it immediately by changing the course to the right. The word horizon has been said, which actually means nothing. In the flight procedure, horizon is, as how I teach my student pilots, that we are talking about keeping the wings of the plane parallel to the line of the horizon he sees before him. According to the reports of the Mack and Miller, the plane would then be barely below the level of the runway, so the execution of this command would cause it to hit the ground. The command, "Go to the other circle," was given by Russian navigators when the plane lost control after the explosion in the wing and loss of the flap. Before that, the Russians had stated that the Polish plane had disappeared from their eyes, although a few dozen minutes ago they were observing the descent of the plane very precisely and carefully, bringing IL-76 and JAK-40. These chaotic actions of Russian navigators were accompanied by their curses, quarrels, and desperate calling for Moscow's help. Meanwhile, Polish pilots approached the airport calmly and precisely. They had no intention of landing, but wanted to make sure that landing would not be possible. The crew was companionate and understood each other. The witnesses perceived the pilots as good professionals, who performed their tasks with particular care for the safety of people flying with them, as well as without the tendency to excessive bravado and risky behavior. The lack of visible signs of personality anomalies or disregard for safety in the name of higher goals confirms the above thesis. There are also no data in the available subcommittee materials that would indicate any shortcomings in the training of pilots. There were no signs of increased tension in the cockpit during the flight. The crew members exchanged standard information on flight parameters and weather conditions. The exchange of information concerning the flight was factual and calm. Individual commands were given and confirmed by the relevant crew members. They were all in agreement and reacted to orders and the command of the crew commander. In the last phase of the flight, there was concentration in the cockpit manifested by the lack of loose conversations unrelated to the task. Situation this was falsely interpreted by the previous commission as silence in the cockpit caused by surprise or shock of the crew and manifested as a kind of decision-making paralysis. Analyzing the whole situational context, it should be noted that this behavior of the crew is proof that the pilots focused strictly on the best possible execution of their action. The pilots had experience in flying with the VIPs, so the flight of the 10th of April 2010 was not a situation causing excessive stress or generating a particularly negative psychological climate for them. The crew was aware of the danger caused by the worsening weather conditions. The actions taken by the pilots indicated properly educated aviation habits and awareness of their skills. The "we're going around" order was issued after making sure that the approach to landing is not possible, which clearly shows that pilots put the safety of transported passengers first. At the prescribed height, immediately after passing 100 meters, the commander gave the command to leave, which the second pilot repeated. A second later, the pilots started leaving in the machine, correcting the position of the plane, including the helm of the height and tilt with slight movements of the yoke. This was carried out in accordance with the provisions of the flight manual. What is more, in 2011, the Prosecutor's Office and the Commission for the Investigation of State Aviation Accidents repeated exactly the same type of departure in order to check if, acting as Captain Protasiuk did, it was possible to go to the second circle. It turned out that the crew of TU-154, number 101, was working properly. This is confirmed by a thorough analysis of the flight parameters recorded in ATM, QAR, and MLP. This fact was obviously hidden from the public. In 2010, a second after the second pilot confirms the command "we are leaving," there is a slight pulling of the yoke towards each other, which causes raising the plane's bow, pitch, and leaning up the rudder, similarly as in 2011. In both cases, after almost 4 seconds, pilots break the autopilot with a strong pull of the yoke to themselves. So the actions in both cases in 2010 and 2011 are similar. But in 2011, the plane slows down the descent speed before the autopilot ruptures, and in 2010, the ATM records show an increase in the descent speed. After exactly 4 seconds, a breakup of the autopilot causes a certain deviation. The fact of leaving for the second circle is confirmed by the Russian navigator reporting to his superiors the course of the crash immediately after the tragedy. A record of his statement is preserved in the Russian version of the talks from the tower, never examined by the Miller Commission. According to the subcommittee, the only explanation for this situation is the manipulation of the records of parameters of the ATM and MLP quick access boxes. As the device we were supposed to read is not the one that was brought in, we interrupt our activities, suggesting that the TU-154, for a moment, was going down with increasing speed, reaching a height even below 5 meters above the ground. The absurdity of this record is obvious, all the more so as the navigator's readings end at 20 meters, from which, according to the regulations, he should give the height every 5 meters. The plane could not be as low above the ground as Anodina and Miller's reports want, because then it would hit Bodin's shed, which, as we know, did not happen. This is confirmed by the opinion of the most experienced pilots. Both departures in 2010 and 2011 were analogous and had to have the same effect. The subcommittee had only copies of the recordings of the recorders installed on board the plane. However, the recorders did not record time from one common clock. Therefore, it was necessary to find time differences between the individual recordings and synchronize them. This was done in reference to UTC time. The graph presented here shows the main events, failures, and alarms in the records of ATM and MLP flight recorders, recordings from the cockpit of CVR and TAWS and FMS devices in the last 17 seconds of the flight. The parameters recorded in the flight recorders can be analyzed in connection with these events after synchronization. One of these parameters is the tilt of the yoke responsible for the change of the rudder position. You can see that about a second after the second pilot confirmed the go-around decision, exactly at the moment when the bell rang, informing about reaching the height of the Q-SIB, the first pilot corrected the autopilot with a light pulling of the yoke towards himself to reduce the descent speed. The autopilot reacted to this correction and changed the position of the elevator. Similar actions were performed during the control flight of the Tupolev side number 102 on April the 15th, 2011. There is a fundamental difference in the aircraft behavior in 2011 and 2010. During the control flight, after correction of the autopilot, the plane reduced the speed of descent, while the trajectory graph of the plane from 2010 shows an increase in this speed, despite the same actions of pilots were performed. Only the cancellation of the autopilot in the longitudinal track was the beginning of the go-around. Another consistent action of the pilot was to break the automatic thrust by moving the engine thrust levers to full range, which increased the engine's rotations. In this way, the go-around procedure was completed. So far, the analysis of the autopilot's direction record, responsible for setting the rudder, has been omitted. It turns out that about 100 meters before the birch tree on Bodin's plot, the plane suddenly started to lean to the left, contrary to the clockwise direction. On the graph of angular velocity of tilt, you can clearly see the moment when this velocity started to suddenly change. The autopilot reacted to this by rapidly changing the rudder position, forcing the plane to slide to the right. This behavior of the autopilot can only be explained by the reaction to the loss of lifting force from the left and the attempt to stop the plane from leaning to the left. As you can see from the diagram depicting the course of the plane tilt, this was only possible for a short time. Further damage to the left wing due to aerodynamic forces drastically reduced the lifting force on the left side, and the rotation of the plane could no longer be stopped. At the same time, a few dozen meters before the birch tree, the recorders recorded rapid changes in the vertical overload. As shown by the comparison with the 2011 flight record and the testimony of the Russian navigator seeing the departure of the TU-154, the aircraft did not accelerate its descent in the last seconds. This indicates manipulation of the radio altitude records in order to attribute to the birch trees the beheading of the wing and causing the crash. Meanwhile, the tragedy actually happened at least 100 meters before the place where the Bodin birch was growing. This is indicated by a precise analysis of the course of events carried out by the subcommittee based on the records of U.S. production equipment, TAWS and FMS, which could not be falsified. Records of the time of events precisely correlated with the location in space, made possible by the satellite map provided by the Allies, show the actual location of the birch and the place of first reactions of the plane to the loss of the wing. It turns out that already 100 meters before the birch tree, the speed sensor of change of the plane's rotation angle reacts decisively, and then the autopilot changes the position of the ailerons and the rudder, putting the plane into the slide. Only a second later the pilots take the initiative. This allows to keep the plane's course unchanged for about 2 seconds. All this happens in front of the birch tree when the plane has been leaving for a few seconds for the second incident. What led to the destruction of the left wing if it wasn't Bodin's armored birch? At that moment, the plane was flying over an area covered with grass and low bushes and a few trees whose trunk diameter did not exceed 15 to 20 centimeters. There was also no field obstacle that could destroy the wing. On the cutoff points of the wing, characteristic post-explosive curls were visible, and the shape of the destruction indicates the explosive nature of the damage. Not without significance is the difference between the shape of the edge of the cutoff part and that which remained in contact with the fuselage. While the former, with post-explosion curls, is destroyed along a straight line, the part of the wing left by the fuselage has damaged upper shell, ribs, and stringers. The effect of the post-explosion wave going towards the fuselage is clearly visible here. The aim of the research was to determine the possibility of linear placement of the explosive in an object imitating a fragment of the left wing fuel caisson of the TU-154M aircraft and the observation of the effects of detonation of the charge in fuel. For the purposes of the research procedure, a 1-to-1 scale model object was built, which is a part of the left wing's fuel caisson, reproduced from the TU-154M side number 102 aircraft. The construction of the object was carried out in aviation plants using materials and in accordance with procedures used in the aviation industry. After a series of calibration experiments, the final experiment with the use of the explosive in a linear form, 1 millimeter thick and 5 millimeters wide, with a total weight of 88 grams, placed in a model imitating a fuel caisson of the left wing, was carried out. The experiment uses rope techniques to simulate aerodynamic forces, acting in a tensile way to avoid the process of burning fuel passing from deflagration to detonation. The applied linear explosive charge with the simulation of aerodynamic forces cut the object into 2 parts. At the same time, the ignition of the fuel was observed, but not its detonation, and the remaining detonation of places of fire were related to the ignition of the fuel residue, an internal sealing compound, which left little sooted traces. The model after the detonation shows features characteristic for the detonation of an explosive material, such as irregularly rolled edges in the direction of the impact wave, so-called post-explosion curls. The research has shown that the applied explosive can be hidden and masked with a sealing agent protecting against fuel and making its detection difficult. The detonation can be initiated by an external explosive material in relation to the inner space of the fuel caisson. What is important, the experimental research on the model of the fuel caisson allowed to observe characteristic traces of the activity of explosive materials visible in the Smolensk case. The explosion exploded the left wing of the plane so that it cut off the end of the plane, and then the slots and wing flap were destroyed, which ultimately made it impossible to balance the loss of lifting power and led to the plane turning to the left wing. The same explosion is responsible for the failure of the chassis, altimeter, and left engine, probably as a result of the breakage of the blast debris. The plane was in the air about 1 to 1.5 seconds before the fall. So, during the fall, the left engine had a thrust and RPM equal to 0. The other two engines had a thrust below 16,000 kilograms. The left engine was mostly damaged. The entire low-pressure compressor was destroyed and torn out of the engine. Rotor blades bent or torn out. But in the best condition was the first ventilator rotor, because only one blade was torn out, but all the others significantly bent in the opposite direction of rotation, counterclockwise. This rotor is made of titanium. The rest is made of dural. Additionally, the steering wheel was destroyed and the engine's body was torn and pushed away from where the left engine fell. Most of the left engine was torn off from the tail on fixing beams. The right engine was torn off from the tail early and probably in the air. After the explosion in the wing and the loss of the wing flap, the plane was already in a hopeless situation, and the tragedy was completed by a total power failure about 15 to 7 meters above the ground. This was a result of the second explosion, this time in the center near the general salon. It was this charge that killed the salon's passengers by scattering their remains over a distance of almost 100 meters, blew up the left passenger door, and so destroyed the left center plane of wing that its first girder burned from the explosion flew 80 meters to the northeast, and the rear part of the hull behind the center plane of wing, with the sides turned outwards, fell 50 meters behind the explosion site. The scattering of parts of falling and damaged branches over 80 meters in the north-south axis indicates a violent disintegration of the plane in the air. Some of the shrapnels also carried characteristic traces, microcraters on their surface, corresponding in shape and size to the traces created on the shrapnels after the pyrotechnic experiment carried out by the subcommittee. This feature is characteristic of the damage caused by detonation. The most terrible thing was the destruction in the center. What happened here could not be hidden even by Russian specialists, who described exactly how the left wing was destroyed by an internal explosion. The top cover torn out, the pants bent down, the ribs torn and destroyed, and finally the first girder of the left wing, thrown tens of meters forward, was a sight that could not be hidden. All doubts about the technical cause of the Smolensk tragedy were eliminated after the examination of samples of the left side remains made in the chemical laboratory of one of our allies from NATO. Not only traces of osmosis were found on the inner side, but also the presence of hexogen, of one of the strongest explosives, was detected. The hexogen was used by Libyan terrorists to destroy a U.S. plane over Lockerbie, to blow up a Moscow subway, and to assassinate blocks of flats in Russian cities before the Second Chechen War. The animation you are watching shows on the left side of the screen these two pieces of the board on which traces of the explosive hexogen were identified. The subcommittee also succeeded in identifying a significant number of parts on the wreck from the epicenter of the explosion. These are, among others, a fragment of the rib number 2L center plane of wing from the district of the county number 41, identified in sector 1, fragment of the girder number 1 center plane of wing at frame number 41, identified in one sector, a fragment of the left-hand side of the first luggage compartment and the third technical compartment with a fragment of the left-hand nose of the center plane of wing and air conditioning components at frame number 41, identified in sector 1. Constructional node of the fuel tank, ballast tank, fixing the girder number 1 center plane of wing, rebate number 41, rib number 3L, identified in sector 1. A section of the port side of the third technical compartment with air conditioning components, identified in Sector 3. A fragment of the top cover of fuel tank number 4 at girder number 1, center plane of wing, identified in Sector 6. A fragment of girder number 1, center plane of wing, located in the structure of the aircraft at the frame number 41, together with opaque fragments of ribs, identified in Sector 7. Directional and height rudder mechanism fixed in the aircraft structure to the girder number 1, center plane of wing at frame number 41, identified in Sector 7. A fragment of the top cover of the fuel tank, number 4, center plane of wing, together with the top cover of the left wing and the top shelf of the rib, number 3L, from the area of frame number 41, identified in Sector 8. Fragment of rib number 3L, fuel tank number 4, center plane of wing, from the area of frame number 41, identified in Sector 9. And a fragment of rib number 3L, fuel tank number 4, center plane of wing, with elements of the fuel installation from the area of the frame number 41, identified in Sector 9. It is of particular importance to identify the place of the explosion center in the vicinity of the structural node connecting different elements of the center plane of wing. It was crucial to find two parts of the hull roof, showing how it was torn apart by the explosion wave. Even today, you can still put these two parts together to see that they fit together perfectly. Could this be the case if the plane was gliding on the ground and destroying the roof by crushing it into the ground? On the above photograph, we can see the wreckage of the plane lying on the ground. It is open and it is lying transversely to the flight path of the plane, with the sides and roof curled to the outside. On the right side, we can see the roof above the right side. In the middle of the picture, we have the bottom of the fuselage. On the left side, there is the left side of the plane, followed by the roof over the left side of the plane. The left side of the plane and the roof over the left side are hardly visible because they are covered with mud clods and branches.
Jeszcze lepiej widać to na zdjęciu lotniczym, gdzie widoczny jest dach nad prawą burtą. Dach nad lewą burtą jest mało widoczny, ponieważ widać tutaj, że jest przysypany grudami błota i gałęziami.
In the simulation of NIAR, the right side, the roof and left side are pressed to the inside of the fuselage.
Oraz dach po upadku na ziemię wgniatają się do środka kadłuba.
No matter at what speed the fuselage would hit the ground and at what angle, as well as regardless of the terrain configuration and obstacles on the ground, each time the aircraft structure will be pressed inside, and at least one of its sides and the roof will be pressed to the inside as well. In this view from the ground, it is clear that during this crushing, there were no major tears in the skin of both the sides and the roof. This is completely different than it was on April 10th in Smolensk. If we take these two photos and compare them with each other, we do not see any analogies here. It is simply a completely different decomposition of the structure. So we have to ask ourselves, what caused such a disintegration and the roof to roll up to the outside of the structure? What was the reason? The only reason for this could be the high pressure inside the structure. This pressure must have been rapid when the airplane fuselage was still above the ground surface. Because if it was on the surface and it would have been detonated, then the roof retraction would have been problematic. But now, in such a configuration as it took place in Smolensk on April 10th, it can be seen that it occurred at least just above the ground surface.
minimum tuż nad powierzchnią Ziemi.
An additional element is the post-explosion curls of shrapnels, which were identified in this area. On the diagram, which is in the right bottom corner of the fuselage cross-section, with a red arrow are marked 2L stringers, along which the fuselage has opened.
Wzdłuż której otworzył się kadłub samolotu.
Here we see in turn the edges of the roof which have been left at the right side of the plane, and the roof over the left side. If we put these edges one on top of the other, it will turn out that they do not have any cavities, that every hole that is numbered due to the torn-out stringers, with the threads will be adjacent to an analogous hole at the other side of the roof.
Do analogicznego otworu przy drugiej części dachu.
This shows that such destruction did not occur as a result of crushing of those fragments due to the crushing of the wreckage, but only due to high pressure in the middle of the structure.
Tylko na skutek dużego ciśnienia w środku konstrukcji. Notabene,
as you can see in this picture, the roof over the left side is cut into two parts. It is not a coincidence that this cut was made mechanically with hydraulic scissors after the event. This part of the roof was also cut off from the left side, so it is practically not visible up close on any ground photo taken after April 11th, 2010. Additional elements confirming the explosion inside the fuselage structure are identified and listed fragments of the left side, which are marked in red, and the right side of the plane marked in blue. The roof is marked in yellow. Groups of these fragments are arranged in such a way that the fragments of the left side are arranged along the northern boundary of the roof. Right side, roof over the right side are arranged along the southern boundary. The distance between these fragments crosswise to the plane's flight path is several meters, even if in some places it was up to 20 meters, because the fuselage structure is at a maximum distance of 4 meters in the contour of the fuselage. So in this case, it is clearly visible that we are dealing with the destruction of the fuselage due to sudden high pressure. This blatant difference between the reality and the lies of the MAK, which could not be concealed, prompted the Russians to act to destroy this evidence. On the 11th and 12th of April, in successive phases, Russian officers cut off the sides of the center plane of wing, so as to make it impossible to identify the true shape of its disintegration. The Russians did not mind that in this way they violated the principles of Appendix 13 to the Chicago Convention. They had a guarantee in the form of a helpless group of Polish specialists that no one would disturb them. Donald Tusk's administration will go over it, and no one will inform either the public opinion in Poland or international opinion about it. At the same time, the same methodology which served to falsify Anadine and Miller's theses allowed to reconstruct the impact on the ground of the first left passenger door, whose flight speed in the last phase repeatedly exceeded the speed of the plane's fall, which confirms that the plane disintegrated as a result of the explosion in the air, even before it hit the ground. This was confirmed by the research NIAR, which proved that in order to hit the ground to the depth of at least 1 meter, these doors needed to reach the vertical speed of at least 120 meters per second. In turn, the aeroplane fell then already slower than 12 meters per second. This additional energy could only come from the explosion. The reconstruction of the course of events according to Miller's trajectory proves that if the plane had been gliding down the wreck with the roof turned down, the door would have folded, but never hit the ground with its longer part. This evidence is sufficient to confirm the analyses resulting from the scattering of the aircraft's remains and the damage in the center plane of wing ballast caisson. Let's see what the crash site looks like 15 minutes after the plane hit the ground. We can see that the area is flat. There is no visible crater. Only small and larger fragments of the aircraft are scattered. In the place marked by yellow ellipse, there are the passenger doors from the left side of the aircraft that are completely buried in the ground, 1 meter deep. Looking at this area immediately after the disaster, it is difficult to guess that under the layer of earth and twigs, there is this door rammed into the ground with the side leading edge and buried almost perpendicular to the surface of the earth. Originally in the plane, the leading edge was the longer door, edged closer to the cockpit. A few days later, the excavation at this place began. In the photo on the left, we can see this door injected like a razor blade into the ground. We see them here from the outside. We also see that the door's skin is smooth, although dirty. The side edge of the door, which was originally closer to the left wing, and in the photo is at the top, is not much damaged. The pictures on the right show the inner surface of the door. At the time of the door ramming into the ground, this side was turned towards the flight direction of the aircraft. The plastic panel of the door from the inside of the aircraft is cracked and covered all over with clay. Under this panel, human remains were found in the inner door structure. These remains had to penetrate the door first, before the door was blasted out of the plane. The lower corner of the door, originally at the bottom near the wing, is completely torn out. Here, in the lower right photo, we can see this door from the inside. It is already cleaned at the storage site and without a plastic panel. We can see the missing fragment near the window edge stuck in the ground. This fragment was found slightly deeper. Above and left, in the yellow ellipses, we can see how this fragment, which penetrated the deepest into the cohesive clay, was excavated. This fragment was torn out by the resistance of the soil, but remained there next to the lower edge. In the red ellipses, or circles, we can see how the soil pressure bent up fragments of the lower edge and a fragment of the upper edge by the fact that these doors were injected into the ground and the resistance of the earth was acting upwards. For the purpose of numerical virtual experiment using the predictive model of the aircraft impacting into the ground, NIAR tested the Miller assumptions. The initial conditions are as follows. The plane touches the ground with the stump of the left wing and the stump of the left horizontal stabilizer. It is rotated 150 degrees relative to its own axis, that is, almost upside down. Its vertical speed is almost 18 meters per second, and its horizontal speed is 76 meters per second. We can see that as a result of the impact of the 80-ton plane into the ground, a vast crater is formed in the virtual experiment, in some places deeper than 1 meter. We can see the north scratch from the left wing and the south scratch from the left horizontal stabilizer. Both progress into the main crater made by the fuselage. We also see the trace of the right wing on the impacted soil as it touched the ground. Such a crater with all the signs we can observe in the results of the simulation is a signature, a testament to the effect of the impact by a particular mass of a particular shape at a specific vertical and horizontal speed. There is no such a crater in Smolensk. Let's see how the passenger door on the left side of the fuselage is destroyed in this simulation caused by this plane's fall into the ground. What will happen to the door? Will the door be buried perpendicular to the ground in the location where the real door was excavated? Let's look at the virtual experiment of the destruction of the door. So the plane and the door fly to the right direction. We can see how, as a result of the impact of the fuselage to the ground, the door twists from the transverse original position to the flight direction. They are bent, twisted, compressed, and stretched, and ripped apart, while some inner door components are torn off and sprayed around. In this simulation, we see the door pushed by the invisible center part of the fuselage along the ground. The visible aluminum outer cover is completely crumpled from the interaction with the ground, and the fuselage that pressed this door into the ground. At some point, the door is freed from the fuselage pressing it into the ground, which at the last moment pulls door upwards, so that it starts to fly and continues its passage above the ground. Let's see it again. Now the door turns into the direction of the flight. Next it is squeezed, bent, twisted, and now is moving upwards from the ground and is already free flying forward. We can see it better if we look at it from the side, like it is shown now. Let's compare the position of the door using the satellite image shown in the upper left part of the slide in relation to the beginnings of scratches on the ground. Here is the real location of the northern scratch, and here is the southern scratch. We see that the real distance to the buried door is 29 meters, and here 31 meters. But from the simulation at 730 meters, the distance from the beginning of the north scratch to the door is 39.6 meters, which is more than 10 meters longer already. And between the beginning of the south scratch and the door at this point is already 47.3 meters, which is more than 16 meters longer. The door that should be buried perpendicularly to the ground in the yellow ellipse has missed this point and has been moved further along the ground to finally fly above the ground, and the door will fly an additional 50 to 60 meters more before falling back to the surface of the ground. We can estimate it using the velocity components chart for this door. First, we can see a negative magnitude of vertical velocity, so the door moves in the direction to the ground with the airplane. Then the door slides on the ground, and here it is accelerated upwards into the sky. And finally, we can see some reduction of positive vertical velocity, while the height of this door continues to increase above the ground. At the same time, the door moves into west within S, Y, Z space. If we examine the real damage to this door again, we can see that the key evidence of the explosion is the lack of a lower corner of the door from the site closer to the left wing. This corner of the door was in this place. The explosion in the left side of the front fuel tank in the plane's fuselage, the evidence of which can be seen on many debris, blasted out the corner of the door in such a way that the outer skin surface was bent outwards and forwards in relation to the direction of the movement of the aircraft. The direction of movement of the aircraft is from right to left. That is, if one considers a possible contact with the ground, then the soil would move relative to this door from left to right. Had there been no explosion, the skin corner of the door would have been pushed inward and backwards relative to the direction of the flight, so the opposite type of deformation of this skin corner would be produced. This damage mechanism can be seen even more precisely on the door frame below the door, where the same shock wave also passed through. We can see the deformation of the structural part of the lower frame of this door. The frame is bent upward and forward, showing clearly the vector of the force generated by the same shock wave. Virtual experiments conducted by NIAR have shown that in order to achieve the effect of injecting the door 1 meter deep perpendicular into the ground and obtain similar damage as the damage in the real door, the vertical speed must be greater than 125 meters per second, and the horizontal speed must be less than 30 meters per second. Since the speed of the aircraft's fall and therefore the door was only 18 meters per second according to the MAK report, much more energy was needed so that this speed could be increased to at least 125 meters per second. This energy, of course, came from the explosion in the fuselage while the plane was still above the ground. It was necessary for the airplane to be above the ground at this moment, so that the door was rammed into the ground, and slightly to the back was able to turn and fly into the ground, rammed vertically like a blade, while reducing the horizontal speed from 75 meters per second to 30 meters per second. The speed at which the door was shot into the ground must have been at least 125 meters per second. We can summarize this analysis as follows. On the left side, we have the results of virtual experiments according to MAC assumptions, and on the right side, we have the real facts. Once again, we can see that the real door has the flat surface of the external skin without any out-of-plane deformations. This door on the crash site was buried perpendicular into the ground, 1 meter deep, with visible damage from the ground pressure acting perpendicular to the edge and tangent to the outer and inner surface of the door. On the left side, we see the results of the virtual experiment according to MAC assumptions. We can see here that there is no way to shear off the lower corner of the door, which in fact was blasted out by the explosion in the fuel tank. Therefore, in the virtual experiment based on MAC assumptions, we do not see the same nature and character of the damage to the door as in the real door. We see completely different permanent deformations and damage of aluminum used for the structure of this door. It should also be added that the Russians were fully aware of the situation. Their description of the wreck remains from September 2010 clearly indicates post-explosion destruction. Not being able to hide the traces of the explosion, they found another reason for it and decided that the centrifuge was burst due to a hydraulic impact of the fuel remains. The absurdity of this thesis was so obvious that Polish prosecutors and Miller's commission preferred to hide this fact and the description of the damage in general, and although they had a full description of the Russian expertise, they did not mention a word about it. The course of events established by the subcommittee is also indicated by a very detailed analysis of the distribution of the remains of the Smolensk victims' bodies. The bodies of the presidential couple were scattered over 40 meters apart. Also, the spread of many other fragments of the victims' bodies, transverse to the direction of flight, indicates the explosion as the cause of their death. For example, one of the passengers was found most to the southwest, but his hand was found in the area most to the east. One of the passengers was dented into the tail of the airplane, means in the direction opposite to the movement of the airplane, so that the crossing into which she hit was wrapped around her. Another passenger, thrown upwards by the blast, flew over the entire center plane of wing and fell into the hollow between the flap and the wing surface. The most terrible injuries were suffered by the passengers in lounge number 3. Some of their bodies were found near the cockpit and other parts at the point of contact between the plane and the ground. The location of the remains of all TU-154M passengers clearly shows that they started to fall out of the plane even before the ground. This would not have been possible if the plane crashed as Anadine and Miller wanted it to, moving along the ground with the sides wrapped up inside. In addition, tiny fragments of bodies, including internal organs, were at the very end of the wreck, where the fuselage was certainly still full. The destruction of the bodies, completely devoid of clothes, shows the terrible power of the explosion which destroyed the Tu-154 and killed the Polish national elite. It should be added that nearly 1/3 of the victims were burned, or even burned in places, although they never found themselves in places covered by ground fire. So there is no doubt that the impact of high energy took place still in the plane. Throughout the period of activity, the subcommittee has analyzed all available evidence on medical aspects. It is very extensive, covering more than 147,000 file cards created by the Military Prosecutor's Office, and little less when it comes to files related to autopsies performed in Poland. To this material, one must also add thousands of photographs from the inspection of the place of the accident and photographs from the autopsy. The members of the subcommittee participated as observers in all autopsies carried out in Poland. The main goal of the subcommittee is to analyze the medical material and determine the most probable causes of death of the victims of the tragedy near Smolensk. To achieve this, a lot of research and analysis was needed. Most of them were performed in accordance with the standards that apply during the investigation of the causes of air accidents. On the basis of these investigations, the subcommittee established the locations of most of the human remains and bodies found in the first days after the tragedy. Another task was to establish the identity of these remains and to determine where specific people were seated on the plane. This was probably the most difficult task, but it was possible to determine the seats of 63 people. The next step, probably the most difficult one, was to develop a pattern of injuries to all passengers. Thanks to all this work, it was possible to establish that the scale of the passengers' injuries is much greater than one could have expected. In 45% of the victims, there was multiple fragmentation of the bodies. 74% of the victims were totally or partially dressed. Very severe burns occurred in 47% of the victims, most of which were outside the ground fire, even more than 50 meters away. A large number of victims were found to have foreign objects stuck in their bodies, shrapnel, rivets, glass, and even fragments of a steel bearing. The bodies were scattered throughout the main field of the remains, and only small fragments were found at the very beginning. Some were driven into the ground 30 centimeters deep. Others were scattered far to the sides of the plane's axis of travel. On the basis of all these studies and analyses, the subcommittee unequivocally concluded that such injuries could not have been caused only by a collision between the plane and the ground. All extensive evidence and the results of many experiments and analyses definitely shows something else. All this evidence indicates that there must have been an explosion on board the plane. According to witnesses' reports, the knowledge about the presence of explosives on the remains of TU-154M was also held by the prosecutor's office and members of the Miller Commission. The ones that showed any kind of device activation, because they checked with two types of device. One general device and one more accurate device. As long as the device with the stripes was not clogged, they were also checked on the stripes. And then it got clogged and we gave it up. They gave it up. These are nitroglycerin compounds, which are found in all kinds of explosives. This is on 60 elements from the seats. Because they are not, there are no intact armchairs. All the elements of the armchairs were packed in plastic bags, so that the bags with these elements could heat up. Because those devices, I said, pilot and MO2, work on the principle of fumes. Every material evaporates. And then we unsealed those bags and indicated two devices, one verification device. If this device was giving a signal, we inserted the second one, a more accurate. And on over 60 bags. I don't remember. I won't say precisely. There were over 60 of them. Despite the obvious evidence of detection of explosives on the remains of the plane, these officers convinced the public that there was no TNT on the remains of the plane. Only when interrogated by the parliamentary committee, the chief prosecutor of the military prosecutor's office, Colonel Artemiak, admitted that TNT was found there. They did, of course, sir. They showed the particles on the TNT readers. The presence of explosives on the remains of TU-154M, both from the seats and from the plane's shells, was also confirmed by detailed analyses of reports of the Central Police Forensic Laboratory made by the Smolensk Subcommittee. The same opinion was issued by the laboratory in Kent, under the Ministry of Defense of the United Kingdom. The evidence collected by the prosecutors in Smolensk was examined there. The results were unambiguous. In both cases, traces of TNT were found, as well as RDX and pentrate, materials used for construction of explosives. The subcommittee decided to check whether any of the parts of the aircraft that were destroyed by the explosion were found to contain explosives during scientific research. Special attention was paid to the explosion in the center plane of wing and port side. The results of the tests were analyzed and collated with information about swabs and sample numbers from the analytical works starting from September 2012 in Smolensk to the recently conducted tests in the laboratories of our NATO allies. As a result of these works, the presence of one of the most dangerous explosives used by terrorists, RDX, known as hexagen, was confirmed. The test in a Polish laboratory showed the presence of RDX, and the test in a laboratory in Oregon, USA. Additionally, it detected the presence of TNT. Separate research was carried out on the basis of swabs taken by the Smolensk subcommittee from a part of the plane, which were exchanged by Russian technicians during the renovation between TU-154 No. 101 and TU-154 No. 102 in 2009. And in this case, a laboratory in Oregon, USA, detected the presence of TNT, and it should be added that it was a part that no one was moving around with the exception of the aircraft being repaired, and traces of TNT were found inside it. Today, thanks to numerous studies, simulations, and analyses, we know that the Miller Commission, as announced by the Vice President of the Miller Commission, Maciej Lasek, was not interested in what was happening behind Poland's birch tree and was not involved in the actual investigation of the Smolensk tragedy. The Miller-Lasek Commission wanted to avoid turning the whip on its own back. It wanted to satisfy the demands of Donald Tusk and Vladimir Putin. It did little scientific research. It omitted or falsified the obtained expert opinions and information under a presupposed thesis. Prime Minister Tusk was blackmailing Poles with the threat of war from Russia, saying in the same, "Back then and today I have no doubt that it is better for Poland to know the truth and not to have a war than not to know the truth and have war." 4 years later, Russia issued the war to Ukraine, seized the Crimea and Donbass, shut down a Malaysia Airlines passenger plane, and the Tusk government continued to repeat the Smolensk lie. The administration, confident in the power of propaganda and political violence, did not think that Poland could afford a real scientific verification of their lies and recreation of the true course of events that led to the extermination of the Polish national elite. Today, we already know that the Smolensk tragedy wouldn't have happened if it hadn't been for the explosion that destroyed first the left wing and then the whole plane and killed 88 passengers and 8 crew members. Such is the truth about the Smolensk catastrophe, the biggest tragedy that fell on the independent Poland after 1945. In memory of the 96 victims of the Smolensk catastrophe, fragment of the last speech of the late President Lech Kaczynski, which he did not manage to deliver on April the 10th, 2010, in Katyn. The murdered people are Polish citizens, people of various faiths and professions, military, police, and civilians. They include generals and ordinary policemen, professors and rural teachers. There are military chaplains of various confessions, the Greek Catholic chaplain and the chief Orthodox chaplain. The world was never to know. The families of the victims were deprived of the right to public mourning, to mourn and to commemorate their loved ones with dignity. On the side of the lie stands the power of a totalitarian empire, the power apparatus of Polish communists. People telling the truth about Katyn pay a high price for it.